Hi guys, it's June 6th. It's like 10 o'clock and tomorrow I have math mock paper 1. Um I'm really hoping to get a good score. Haven't really studied much, but I think I can do most of the things. I'm pretty fast. I think that I have to really focus on being slower and making less silly mistakes. I haven't done much preparation for this, to be honest. I don't think it'll be a problem though. I think because it'll be more of a cumulative thing. And I do like roughly know the main points of everything. Yeah. Hope and pray.
Hello everyone, fellow HL math students. We're just done with the math, I can't even speak English. The math exam, the math paper 1 exam. How did it go, George? I think it went great compared to the quizzes actually and the midterms. I also think it went really well. I was sneezing all the time. I don't know why, I might be allergic to air conditions or something. It was terrible, but I got a bunch of cool answers. Frank agrees, so I think I did well. George, hello. Good luck for everyone doing their exams. And honestly, don't study for Math AHL. Yeah, don't study. This exam wasn't that bad. It could have been much worse. Do we agree?
We agree.
Yeah, and I would say honorable mentions the SL student, but they're not really honorable, so just have a quick glimpse. There you go. Bye, guys.
So I wanted to give some more details on the actual exam. So traditionally, math paper 1 has always been better than paper 2 because you can always verify your answers, and once again this turned out to be the case. I mean, I haven't seen paper 2 yet. Apparently paper 1 is harder according to the teacher, but I don't believe it. It was a cool exam. It felt like I was going quickly, but I was getting the right numbers. At least I hope I was getting the right numbers because everyone seemed to be able to corroborate my numbers. And then there were also a bunch of questions that said, show this. And for those questions, I mean, you kind of know if you made a mistake or not because you either show it or you don't. Yeah, I left every question, I answered every question. The last question was an induction. Wow, I spent so long on this. The last question was an induction, it was a pain. It eventually got to a spot where you had a quadratic in the numerator and a cubic in the denominator. And you had to show that that was equal to k plus 1 over k plus 2. Eventually I got it near the very end. I had just finished my exam. I had looked over every single question. I hadn't finished the induction, and I thought maybe I should try one last thing, and this ended up working. What you had to do was factor out k plus 1 in the numerator, which was reasonable. Like, it was pretty simple. Like, you could do that. Then you were left with a bunch of other like ugly things. Then you had to rewrite the denominator as those ugly things and k plus 2. And the expansion just ended up working to what the denominator was. So you could do the expansion, it was correct, but there's no way anyone would ever like get the factoring because it wasn't given, like there was nothing, but you had to sort of guess it. Well, not guess because you roughly knew where you wanted to go. And I did that step. It was very near the end. It was like halfway through the 5-minute marks, and I got the induction. Really happy, 9 marks. Yeah, there were a bunch of tricks for like with quadratics and getting annoying big identities for like complex trig functions, but I got them. I had done a very similar question a couple of days before where it dealt with like a quadratic that had root of like cot pi over 8 and tan pi over 8, and the question in the exam that we had like cosecant of pi over 6, and like I don't remember, but similar concept. Actually, it wasn't that similar, but I was definitely inspired. It felt like I could just work through everything. I didn't did I get stuck? Oh yeah, there was a question. This was like the 4th question. It had a bunch of logarithms, and I didn't really study logarithms. I felt confident, but you ended up getting an equation with a bunch of different logarithms, all base 3, but you also had a 1 over 2 somewhere. So I got this right because I got 1 over 2 in the end, and it matched everyone else's answer, and it makes sense. But it was very weird because you had to multiply everything by 2 and then make the 2 an exponent as per the log power rule. And it was very weird initially because you got an x to the 6th, but then it worked out to be x to the 5th, and you got x to the 5th is equal to 1 over 32, which is 1 over 2. Very glad that worked. Sometimes you have to keep them going. Oh, there was a cool integral question where you had to do trig. They gave you the trig sub. It was slightly tricky, but I got it in the end. And the good thing with integrals that you get a neat answer and you know it works. For example, I got tan of r cos x, so pretty, hopefully reasonable. Yeah. Let's see what else was there. There was one question which I answered, although not correctly, and I know it's not correctly because I actually didn't review this. This was the very last thing we did in class, and to be entirely honest, I didn't really learn it properly. It had to do with advanced binomial expansion, so for any exponent. So that question, part A, it said rewrite a complex fraction in terms of 2 partial fractions. Okay, pretty simple. Although someone afterwards said that they got the same values as me, but they checked it and the numbers didn't work. So who knows? We'll see, I guess. Then part B said to list the first 3 terms of that binomial expansion. So you basically had in the first part a linear function over a quadratic, but which would be annoying to expand. But thanks to the expansion that you had done in the first part of the question, you just had to expand a coefficient over a power of -1. Well, not over power of -1, a coefficient times the linear function of the -1, and combine them. You have to find the first 3 terms. I got an answer for that, but I'm not sure it's entirely correct. Some values might be off, some digits might be off. I didn't spend much time on this question because it's the one that I didn't really know entirely how to do. Then the last part, it was a 1-mark question, but I had no idea how to do it. It said find the values for which the series converges, but it wasn't geometric, and I guess that's what you get when you don't prepare that part of the syllabus. There was another cool question. It had some contradiction. I had not studied that in months, but I got it. Contradiction is pretty simple. You just have to assume the opposite and prove it doesn't work, but I was still pretty happy I got it. Then there was another question with the graph. It asked for the graph of two composed absolute value functions. So absolute value of x minus 1 plus absolute value of x plus 1. I had no idea how to do that, so I did the only logical thing and I plugged in 5 test values until I got the shape. Thankfully, I checked the graph on Desmos and it was right. And then it asked you to find the area between this function, so the absolute value function, and the line, and it ended up being 4. I checked it on Desmos and it's also 4, so I hope that I found what the question wants me to, because some other people found some other things like 44, but some other people also found 4, so yeah. Let's see what else. Ooh, there was the very last question was pretty straightforward because it had a question about transformation of functions, which I did not really know, to be entirely honest. I mean, I think I got it, but maybe I got the sequence wrong. I mean, I know translations and that's it. I know translations, but I'm not sure what's a vertical stretch, what's a horizontal stretch, when the scale factor is the number, when the scale factor is 1 over the number. I'm not too sure about that. But I wrote some stuff down, hopefully I can get some of the 3 marks. But then the rest of the question was basically show that this is this. So pretty straightforward. One of them had a bunch of tricks needed, where what I did was you had an arctan kind of function and you have to show something, and what I did was take the arctan of the tan of the arctan. So you have the arctan of a double tan identity, which ended up working nicely. It worked. Not the most efficient. Yeah. Tomorrow's math paper 2 in Spanish. Bye guys.